grew up in Arlington, so I've been a native with this area for quite some time and been in Maryland for the last 20 years. And so I've done a lot of speaking over the last, let's say, 15 years in Maryland and Virginia and kind of local code camps and user groups, always kind of in the Microsoft stack. And the last 5 years, I've been at Microsoft, specifically on the Azure team, and even more specifically on the Azure Government Engineering team. I'm fortunate to be on a team locally with some really great engineers, and we're very much focused on enabling government customers at Microsoft. But as part of that, I've had an opportunity over the years to kind of stay enmeshed in the core languages like C#. Every time C# comes out with a new version of the language, and we're going to be talking about C#9 today, which is interesting because C#10 is actually coming out very soon. So we could be back here in a couple months doing the next version of this talk. So with that, it looks like it's 1:59, so I'm going to just roll into the presentation here. Okay, so I only have 2 slides, and then we're going to spend the rest of our hour long here together looking at code and doing demos. So I'm just going to show 2 slides, and every time I give a C# talk, I really like to sort of start with a history lesson, because when you look at the new features that are added to C#, I think it helps if you understand the historical context for a lot of this, and it helps understand, well, why are they adding this to the language, and what are the things that come before it? So when I go back to C#1, I can't believe it's almost 20 years ago I started C#, feeling very old now. Even out of the gate, C#1 was a pretty robust object-oriented language, full support for object-oriented constructs, inheritance, in interfaces, all those sort of things. And then C#2 came out in 2005, and that corresponded to .NET version 2.0. And that had lots of features that were added to the language at that time, like static classes and iterators. But without a doubt, the sort of headlining feature of C#2 was generics, which allowed us to write code in a much more type-safe way. Then .NET Framework 3 came out, but that was not a new version of the C# language. That was about a year later. And then about a year after that, in 2007, C#3 came out, which corresponded to .NET Framework 3.5. And this, again, had about a dozen new features like Lambda expressions and extension methods, anonymous types, and type inference. The list goes on. But without a doubt, the headlining feature of this release was LINQ, the language integrated queries. And even a lot of those features I just mentioned were really features that were strong features that could stand alone on their own, but also when you put them together, really helped make the implementation of LINQ much more elegant. Fast forward 3 years, we're now at 2010, and that C#4 came out, and that corresponded to .NET Framework 4. Only about 4 features were introduced in this release, things like named and optional parameters, covariance, contravariance, some com interop enhancements. But the main, again, headlining feature here was dynamic. We had the dynamic keyword, and the big joke was we could statically type something as dynamic. 2 years later, 2012, C#5 corresponded to .NET Framework 4.5. Not a lot of language features here, except for the big one, which is async and await. And that really helped us write asynchronous code in a way that was much more understandable to our feeble human brains. And we didn't have to go in reverse. We could think about the code much more rationally. Now, one of the things you're going to notice up until these first 5 versions of the language, every time I've mentioned new versions coming out, you've always heard me mention something like the headlining feature. Every time we've done a release, there's always like that headlining, really the feature that gets all the attention every time a new version comes out. Well, C#6 was an interesting release because this is the first release that sort of deviated from that paradigm. So in 2015, we had C#6, which corresponded to .NET Framework 4.6. And there was not really a big headlining feature like generics or LINQ. It had some cool features. Absolutely. Features I use every day. String interpolation, auto property initializers, getters only, expression body members. I guess if there was one kind of headlining feature, it was Roslyn. Roslyn not necessarily being a language feature we use every day, but the C# compiler in a box, which enabled some interesting C# features that weren't possible before. 2017, we had C#7 along with a bunch of point releases that, if you weren't paying attention, may have just escaped your attention. And that was the first one that really corresponded strongly to .NET Core. That was .NET Core 2.0, but also worked with traditional .NET Framework 4.7. And C#7 introduce tuples and deconstructors and local functions, pattern matching, out variables, digit separators. A lot of these things are just really, again, not game-changing features. A lot of them are just nice to haves. And what you start to see here at this point, C# is 15 years old. It's a pretty mature language at this point. So you don't necessarily need to introduce some paradigm shifting feature into the language anymore because it's pretty fully featured at this point. And so you start to see these point versions 7.1, 7.2, 7.3. You get nice to haves like async main for console applications and inferred tuple names, digit literal expressions, private protected, things like that, and some additional tweaks. Now, C#8, that had some more features. So that was 2019, that corresponded to .NET Core 3, and that had more pattern matching, indices and ranges, static local functions, probably nullable reference types was the main quote-unquote headlining feature. But again, those were optional. It didn't force you, just like dynamic, C# doesn't force you to use dynamic. It doesn't force you to use nullable reference types. So up to this point, this sets the stage for .NET, for C#9, which corresponded to .NET 5. And that was in 2020, which is last year. November of this year is where we're targeting releasing C#10 with .NET 6. So that brings us to our agenda to today. We are going to cover all 12 of these features and more. And don't worry about what all these things are right now. I'm just giving you a preview of what I'm about to show you in code. So with that, let's jump over to a demo. So first thing I'm going to do here is create a new project. I'm just going to use Visual Studio 2019. The other thing I'm going to do is I'm going to turn off my video because sometimes when I have my video going, it can slow down my machine. And so I don't want that to happen. So let's just put this in my dev folder and we'll call this CS90 demo. And I'm just going to create this from scratch. Yes, we're using .NET 5, which is the current release of .NET. And I'm just going to create a console application where I'll be showing these various features today of the C# 9.0 language version that I just mentioned. Okay, now, one other thing I want to point out is if I double click my project file and look at my CS proj file, you're going to see that, yes, it said .NET 5.0. And if I right click my project over here and say properties, this is where you can come in and say, all right, let's make this .NET 3.1. Let me save that. And you'll notice the change it just made to my CS proj file here. So that is where you're going to see the difference. The upgrades are very straightforward and easy, but I just wanted to show no magic happening there. That's what's showing us that we are on .NET 5. And I just have the typical hello world program, which if I do Control F5 just to run it, make sure everything's working, we will see hello world. And there you go. Now, one thing that a lot of times when people look at these console applications, these hello world applications, you're like, okay, so you wrote hello world to the screen and you needed 13 lines of code to do that? That seems like a lot of ceremony that you just had to go through to write hello world to the console window. And you've got this using up here, you've got this namespace declaration here, you've got this curly brace, now you have a class. Why do you have a program class? Now you have another curly brace. Now there's some weird static void main thing. I don't exactly know what it means, but it was auto-generated, so I guess I should trust it. Then we got some more curly brace, curly brace, curly brace. And so, when you look at people that come from other languages and then they come to C#, they're like, why do you have 13 lines of code to write hello world? Wouldn't it be nice if I could just remove that namespace declaration and remove that curly brace? And while we're at it, wouldn't it be great if we could just remove that class and that curly brace? And you know what? Why not remove that main method too, and that curly brace and all these curly braces too? Wouldn't this just make a lot more sense in terms of like making the code something a little bit more understandable? And if we just run this, wouldn't it be nice to just run this and say hello world? And in C#9, yes, you can do that. And so what we do is we call this top level statements. So it's really just taking a lot of the ceremony out. Now, if you're doing like an ASP.web app, ASP.NET web app, you're not going to use this. But for simple console applications like this, it's pretty handy. And just to get rid of a lot of that ceremony, and you look at these other languages like Node and Python where you don't have this type of ceremony, it's just simplifying things, especially for developers that are coming into the language for the first time. Now, the other thing I'm going to do is let's insert a few classes here. I have a class called contact, and that has a first name and a last name. And I'm going to put, instead of hello world, I'm going to just write, instead of hello world, let's just put a Sorry, my fault. I'm just going to put a little section of code here. And what I'm doing here is I'm instantiating a contact object and I'm right-lining first name and last name. No C#9 at this point. This is just very straightforward C#. I'm using string interpolation from C#6. But that's it. I'm using an object initializer that we had about 4 languages ago, and I'm just outputting my name. So nothing too interesting there. But now we have this top-level statement. Now, another thing to notice about top-level statements is once I start instantiating types like this class declaration, this has to be at the bottom. In other words, if I take this console write line and stick it at the end, it's going to say, no, I'm not happy with that. If I try to run this, you notice I'm getting the red squiggle because it's going to say that when you're using these top-level statements, all the top-level statements must precede namespace declaration and type declarations like classes and things like that. So it has to be moved up here. So I'm just going to put a little placeholder in here that says stuff below top-level statements. So you want to think about this as like everything above this line is your main method. So everything above this line, think of this as your main method. Sorry, above this line. And everything below is anything else like private methods or classes or that kind of thing. Okay, so just a rule to know when you're using these top-level statements. Now, let's go one step further here. Notice that we have get and sets. We've had this for many versions of C#. What we now have is the ability to have an init setter right here. So what this is called is an init only setter. Now let me show you what the effect that has. So here I use an object initializer to set first name and last name, that's fine. And when you do that, that's actually using the typical setter. So if I come here, the init is saying you only get to use it in that context. In other words, if I came in here and typed this line of code that said first name equals Bob, notice that it's giving me a compiler error saying init only property or index. That's you can only use that in an object initializer. So here good, here not good. So init only means you can only use it in an object initializer, which is what this is right here. So that is a new feature of C#9, mostly used in C#9 records, which we'll get to in a second. But they can stand on their own, and you can use them in traditional classes just like this. And so because they are a standalone feature, I just wanted to call it out here. Another thing I should mention is that all the code I do in this presentation, I'll make freely downloadable to everybody. And so I'm not going to delete any code. I'll comment out a lot of code that I'm not using anymore, but I'm not going to delete any of it because I want everyone to be able to recreate my demo. So I'm going to leave a lot of these comments in the code like C#9 features. So you'll see those little placeholders for all the features that I cover here. Okay, so let's get rid of that line of code that was causing us the compiler area. Now, the next thing I'm going to do is I'm going to change this class declaration to record. And we're going to talk about the implications of this, but fundamentally, what you have to know is a record actually is a class. In fact, I'm just going to do Control F5 here to run this for you, just to kind of prove to you that nothing has changed behaviorally. What you're going to get with records is this idea is that as the years have gone by, many C# classes, when you look at them, they're really just glorified data holders. There's a lot of boilerplate code required. And the other thing is, a lot of times we just want to assign the values right at the beginning. And immutability can be enhanced by things like value-based equality. You see some of these other languages like F# that go really to the extreme in immutability. And when you have that type of situation, you have easier parallelization when you're writing multi-threaded code, and you're always in an always valid state. So I can use my object initializer and say, boom, I'm in a valid state. And you notice when I tried to assign Bob to the first name, some classes, if they're not intended to be immutable, then yeah, that might be a valid case. But a lot of times that's not the case. We don't want to assign first name a null or a different value. We just want to have them in an always valid state by just initializing all properties at once with an object initializer. And so immutability typically reduces risks. It's a little safer, helps prevent bugs. And you even see this in frameworks like React, which really has like an immutability paradigm. And you see a lot of frameworks and languages going this direction. So with that, let me talk a little bit more about what we can do here with records. Let's dive a little deeper into what we mean when we're talking about C# records. So I'm going to come in here and I'm going to create contact2, and I'm going to say it's equal to the contact above it, which was Steve Michelotti. But then I'm going to use this with keyword and then a thing that looks like an object initializer. And this time I'm going to say first name equals Justin, just use my son's name here. And then under here, let's console write line contact2. A couple things we're going to observe. What you're going to notice is, okay, there's the Steve McLotty we always had. Now with the second one, notice I just output the object itself. And so, but we got a nice little two-string method that was sort of generated for us that enumerated every property that was in my record class and just output it all right there. The other thing you're going to notice is I set it that contact2 equal to the first contact, but then I changed the first name to Justin. So here's the change to Justin, but then the last name being Michelati is what it just sort of got from the first class when it sort of copied it, so to speak. Now remember, you heard me mention before, a record is a class, meaning it is a reference type. It's stored on the heap. There's nothing magical happening in that perspective. But this is ability to say, okay, I'm doing the with operator gives me easier object initialization, especially when we're going from one object to another object and that sort of thing. Okay, so let's keep going. Let's do another example here. I'm going to say contact3, and we're going to say this equals to contact2 with, and this time we're going to say first name equals to Steve. Now what's interesting about this, and let's just output it here to prove that it is what we think it is. So I changed it to Justin. I changed this to Steve, which, by the way, matches what we had to begin with right up here. So this contact3 should output Steve and Michelati. Let's run this and prove it to ourselves. Sure enough, there's a Steve McLotty here, and there's Steve McLotty here. Okay. Now there's some interesting implications that happen when you do something like this. So I'm going to output another snippet here to just show this example. And if you look at what I just output 3 different equality comparisons. The first one is an object equals. And I'm doing the first contact to the third contact. The 2 Steve Michelatis is what I'm comparing. Here I'm doing the double equals comparison. And here I'm doing reference equals. But in all 3 cases, I'm comparing the 2 Steve Michelatis together. So this is going to illustrate the example of reference equality versus value equality, so to speak. So let's run this. And what you're going to see is the object equals is true, and same with the double equals, because essentially what is happening there is we're going through and it's comparing property by property. Did the first names match? Yes. Did the last names match? Yes. But then when we get to reference equals, that's false because they are, in fact, 2 different object references. And so again, that's a very important thing to take away when you're talking about records and that sort of thing. And it simplifies a lot of the object comparisons for equality and that sort of thing. Okay, now another thing I want to show is this. What I'm going to do is I'm going to just copy this code here, and I'm actually going to comment it out because I want people to be able to recreate the demo. But when I look at this, we talk about a lot of boilerplate code, and I know these are always gets and inits. Wouldn't it be nice if I could simplify this? So I'm going to come in here, and I'm just going to come in and say string first name, string last name. And now I have in one line of code exactly what it would have taken me before to do 1, 2, 3, 4, 5, 6 lines of code. All right. But everything is still going to run exactly as we think, except now that I've gone with this syntax, notice I'm getting this red curly brace here. Now that I've gone to this syntax, we can do the object initializer with a slightly different syntax. So here I can just say Steve Michelati, and it almost basically looks like a constructor. And now when I run it, everything just works. So it's still these with statements that look like object initializers, these still work. And so you've seen these, some of you may have seen a language suggestion over the last couples that almost made it in called primary constructors. I think it's making it into C#10. This looks similar to primary constructors, not exactly the same thing. Now it really lets us simplify. Another thing you might say is, well, yes, but how do I know which one is first name and which one is last name? You can still use named parameters, which we got in C#4. So for example, I could still come in here and say first name, colon, and last name colon, just because I say, well, I feel like that's more readable. Cool, that works too. No difference. Compiler doesn't really care. This is just for your own preference in terms of human readability. But there's a lot of flexibility you get with records. So let me keep going here, and I want to show a couple more examples. So down here, where I have the record as contact, I'm going to introduce another record, and I'm going to call this business contact, and it's also going to have a first name and a last name, but it's also going to have a company. And I'm going to have it inherit from the regular contact. So we'll just use inheritance syntax here, and I'll just pass the first name and last name to the constructor of the base class, and there we go. Okay, now with that, what I can do is I'm going to come in here. I'll just put it down here, I guess. I'm going to create a new business contact. And we're going to call this guy Bill Gates, and his company is going to be Microsoft. Yes, I know. I should probably say Gates Foundation, not Microsoft anymore. But that all the inheritance stuff still works. And well, actually, I didn't output him. That's OK. Let me do this instead. Another thing I want to show that record supports is deconstructors. So I'm going to say fname. And then lname, that's just the name I feel like giving my tuple here on this deconstructor. And I'm going to set this equal to business contact. And I'm just going to do a console log right here. And then I'm on this console log, I'm going to say the deconstructed values are fname, and I'll just put a little comma in here, I guess, and lname, and that's it. And this right here is using a CSharp9 deconstructor. Let me make sure I spell it right. And I'm really illustrating this example just to illustrate that deconstructors are automatically and natively supported in CSharp9 records. So if we run this, what we're going to see is we have this tuple with these two local we deconstructed into this tuple of local variables. There's the what I called the fname variable, and there's the lname variable. I could have called those whatever I wanted, but we can still deconstruct values. And it happens automatically, so the deconstructor will include every property that you added to the record. Now, up to this point, you may be saying, okay, like a lot of this seems kind of magical about this stuff that's happened. I'm kind of curious, like what's happening behind the scenes? And I always like to look at what's happening behind the scenes. And traditionally, I've used tools like Reflector to look at some of this stuff. What I can do now is I'm going to right-click my contact object, and notice this little command that's built into Visual Studio here, open code in ILSpy. I don't need Reflector anymore, and everyone got all upset when Reflector used to be free and then we had to start paying for it. You don't have to worry about that anymore. I can get ILSpy for free from Microsoft. And when I open the code in ILSpy, what we're going to be able to see is when we are using these language features, what's actually happening behind the scenes. So for example, here is the contact method. Let me come back to C# here. And I am going to set this to C#8 so it doesn't hide any of the language features we just used. So here is the record class called contact that I just created. Notice behind the scenes, it's a class. So even what I said before, a record is a class. It is a reference type. It is stored on the heap. Now I'm proving it to you. You don't have to take my word for it. It actually is a class. The C# compiler knows, or I should say the .NET runtime, the concept of a record does not exist. This is truly just a C# feature that the C# compiler compiles into a traditional class. But it just gives us those convenience constructs to make our code more type safe and immutable and those type of things. Notice it also implements IEquatable of contact. And if we go down the road here, if we go down the list, we can look at the toString method. And if we look at this toString method, notice, remember when we got that nice little toString that was showing first name and last name for like Steve Michelati and Bill Gates? You can see that it shows here's the name, here's the curly brace. It calls this method called print members, which is right here, which essentially generated this list of sort of iterating through every property and outputting the result. And so that nice little toString method that I showed you, well, it's not magic at all. It's the C# compiler behind the scenes generated that for us. And then Remember, I also showed some of those equality comparisons, like the double equals and the reference equals and that sort of thing. And sure enough, that's not magic either. If we just look at what got compiled behind the scenes, this is what actually got generated. And remember the deconstructor I showed with fname and lname? Well, that was generated as well. This is code that I could just write in C#7. In C#9, if we're dealing with records, it just wrote the code for me behind the scenes. It just generated, the compiler generated that code. So this is what's actually happening behind the scenes. So I like to show this to demystify this for people. I love records. I love the succinct syntax that it gives you. But behind the scenes, these are just C# classes. It's just a whole lot less amount of code that we have to write. Remember here where I just have a class with 2 properties, right? But I had to do like 6 lines of code for it. Now it's just like you can just do a 1 line of code for that kind of stuff now. So I really like the syntax that it gives you. Okay. Now another thing I noticed here is I started thinking to myself, like, wow, this really, the fact that they're forcing you to initialize this stuff, it almost feels like this would simplify some of the nullable reference types that we would get in C#8. And I started experimenting with this a little bit. And so here's a traditional address class that we would write before, but notice I have the init right here. Now let's say we turn on C#8 nullable reference types. So I'm going to come in here and we'll go to my CSproj file. I say nullable and we'll say enable. Okay. So when I do that, what we're going to notice is that what starts to happen is now we are getting these squiggly things under here saying, well, this is non-nullable, must not contain a null value. You've got to make sure you have a constructor that declares all this stuff. So we got to force that, make sure all the projects get assigned, and we would have to do all these. Now it's additional ceremony to have another constructor that has all 4 of these and assign all these in the constructor. We don't have to worry about that with records. With records, it actually makes the nullable reference types a lot easier to deal with because we can just do something like this where we say, well, there's street address, there's city, where this is going now, here's state, and here's the zip code. And instead of having to add additional lines of code with all this extra ceremony, now we really just have 1 line of code. So instead of going from 6 lines of code to 12 lines of code, we went from 6 lines of code to 1 line of code. Now still giving me the red squiggle because I forgot to say record here. But once I do that, now it's happy. So what I realized is that using records even makes the implementation of C#8 nullable reference types easier to work with as well, and enables us to remove a lot of that ceremony. So in terms of a sort of decision tree, if you will, the way I think about is when you should use records as when you have data structures where things point to other things, you need reference types, like a contact has an address and that sort of thing. But if you want it to be value oriented, like it's really just a data holder, or you have inheritance and you want immutability, records are a great choice. So remember, references that are mutable, those are just traditional classes. When I say mutable, what I'm talking about is like you need to actually assign the first name to a contact after it's been initialized. You really need it to be mutable, then use traditional classes. But if it's really just like, hey, here's my data holder that I can assign everything at one time, records are the ideal choice for that. Okay. All right, now with that, let's move on to the next features. Now I spent more time in records than some of the other features because a lot of these go a little bit quicker. And since records was sort of the headlining features, I wanted to spend more time with that. Okay, so the next thing I'm going to show here is I'm just going to hit return a few times. And we're going to go to the next demo here. So if I come in here and say list of ints, code I could have written in C#2. Now I'm getting a red squiggle because it wants my namespace here. So put my collections generic namespace up at the top. Now, if I look at this line of code here on line 22, this is code I would have written in C#2 when generics was introduced. Now, the thing about this is it's kind of verbose, like list, angle bracket in, angle bracket, and then new list, angle bracket, angle bracket. So it's a lot of code to write. What we could do to improve this is say var list, and then our code is less noisy, less angle brackets, less noise, and this is a little bit of a cleaner way to do it. And here we could do this in C#3, implicitly typed variables, implicitly typed vars, okay? Now, what we can also do in C#9 is that we can write it this way. We can say list of int, kind of like that first example, equals new. And what you're going to see is it says, hey, you already told us that it was a list right here. So why do you have to tell us again? When we say new, trust me, this is the constructor for a list. Actually, no, don't trust me. Make me prove it to you. So if I come in here and look at my IntelliSense, notice that I have 3 different constructor types right here. And if I start scrolling down on these 3 types, you can see like, oh, yeah, capacity, I recognize that. Yeah, that is the constructor we get. That's the traditional constructor we get from a list. You can see it is the list constructor. I can say, let me set the capacity to 100. In fact, if I have my cursor over the new keyword and just hit F12 to go look at the definition, sure enough, I mean, it jumps you to the list constructor. So again, this is just syntax candy. But it's, I guess, important syntax candy because it lets you do these things in a little bit more of a nicer way. So this is what we call target typed new expression. Is it a life-changing feature? No. Is it a nice to have on an everyday basis? Sure. Use it if it makes you happy. Don't use it if it doesn't. Okay. Now let's also point out that, like, if I look at line number 5, we can do these with records as well. So if we look at line number 5, where I said var equals new contact, I could say contact instead of var. And once I do that, I can just delete. Now, this is still using the constructor for the contact. It's the record. Nothing's changed. Compiler is happy with it. It just allows us to use these target type new expressions with traditional classes, with records. It just sort of works everywhere. Okay, so let's keep going a little bit further. What I'm going to do is I'm going to come back to this business contact, and let's copy and paste that. And I'm going to call this a personal contact. And instead of having a company, the person is going to have a hobby. And what we'll do up here after our Bill Gates example, I'm going to have personal contacts. And let's make this one, let's just use the target type new expression for the fun of it, personal contact. And let's make this a new personal contact. And this is going to be Bob Smith. And Bob's hobby is music. Okay. Now, one thing I want to show is that you can actually have conditional expressions. Let me show what I mean by that. In both cases, the business contact and the personal contact, they are both inheriting from the contact object. So what I can do is I can say contact, and we'll just call this C, equals, and I can use a little ternary here where I can say the business contact dot first name equals foo, little bit of a nonsensical example, then assign it the business contact, otherwise assign it the personal contact. So prior to C#9 does not compile C# 9.0. So this is one of those instances where you look at it and you're like, well, what's the big deal? Of course that works. Well, it didn't work prior to C#9. And people say, well, why doesn't that work? That should work. And you're right, that should have worked. But the language team didn't have time to get to it. So in C#9, we got to it. So I shouldn't say we, I'm not on the language team. So the Microsoft team got to it in C#9. So what we're talking about here is this is an example of target typed conditional expression. I think this is more of a feature that you notice when you don't have it versus a feature that you notice when you do have it. Because this, like I said, it's one of those things where you're looking at it and it doesn't compile. And you're like, why doesn't this code compile? Of course this compiles. This is like contravariance here when I can take a more derived type and assign it to a less derived type. But that's like object oriented. Of course that should work. So, and now that limitation has just been removed in C#9. That kind of thing will now work. Okay, so let's keep moving here. So I'm going to show another example here. So C#8 introduced a bunch of pattern matching features, and C#9 actually sort of like just continues to build on that. So what I'm going to show here are, I'm going to, there may be some people that saw me present on C#8. If not, that's also fine. But what I'm going to do is I'm going to actually pull over a file that I used in my C#8 demo like a year ago called Premium Calculator. And you can see I've already got it annotated with a bunch of C#8 examples. And so this might be a little bit of a review from C#8 as well. But now we have additional pattern matching enhancements in C#9. So with pattern matching, this is a premium calculator for like auto insurance, right? So if the vehicle cost is above $100,000, my premium's $1,100. If the vehicle is $60,000, then it's $800. If it's $20,000, it's $200. And notice I'm using the digit separator that was introduced in previous versions of C# as well. So these first three lines of code, I'm not even going to copy them. I'm going to comment them out because I'm going to show, well, what does it look like to look, we can still do that syntax if we want to, and there's nothing wrong with that syntax. But with the new features that we have in C#9, what does that syntax now look like for those three lines of code in C#8? What does it look like for C#9? So what we have here is we're going to use the switch expression again that was introduced in previous version of C#. Now I can just say, since we're switching on the vehicle cost property, I can just say the vehicle cost is greater than 100,000. Essentially, then it's 1,100. And if it's greater than 60,000, and when old crusty C# developers like me look at this, you're like, well, wait a second, how does this possibly work? Like you're saying greater than, like there's nothing on the left side here. What are we comparing greater than to? Well, it's comparing it to this, and so it's just saving us a lot of the ceremony we would previously have to do in C# where we say vehicle cost is greater than 100,000 and vehicle cost is greater than 60,000 and vehicle cost is greater than 20,000. It just saves a lot of that repetitive typing and ceremony and now allows us to write it like this. So I've written that code, although now because it's a switch expression, it says, well, you've got to cover all possible paths, and it's not exhaustive yet because I haven't covered the path that's under 20 grand. So I can just add an additional switch over here that says if it's less than or equal to 20,000, then that'll just be $100 here. And now the compiler is happy. So we have greater than, we have less than, we have less than or equal to, and we have different things that we can use here. And we can also combine some of these things together. So on this line where I said greater than 20,000, I could have ands in here as well. So I can say and less than 60,000. Now, again, for some old crusty C# developers like me that might be watching right now, you might be looking at this and being like, wait a second, this is a bug. This should not be AND. This should be like a double ampersand like that. That's how we do AND in C#. Well, actually, yes, but not in the case of the pattern matching. In the case of pattern matching, that's a differentiated AND. So we're saying, in this case, we do it just like that. Now, and that's only in the context of these pattern matching expressions. Otherwise, that's the only place we can use AND. Otherwise, yes, we must still use the double ampersand. So don't worry about that. We're not, changing anything crazy there. And you can even combine this thing with like parentheses and ands and ors. So I could put this and statement in parentheses and then say an or, and then say, or if it equals 1,000,000. Again, a little bit of a silly example, but if it happens any of those conditions, then it equals 200. So we have parentheses and then essentially an equals condition right here. Any of those things, this value is true, it results in 200. And just some other minor things. And so I'm just going to actually, let me label this here. So C#9 feature, I'm just going to say additional pattern matching enhancements. And then another thing we can do down here is in C#8, this open and close curly brace was essentially like you have an object, but like you didn't take into account of all the conditions that came above it, so we don't really know what to do. Now you can essentially do the same thing where not null, that also works too. So that's additional pattern matching, specifically the not null. Functionally equivalent to the open and close curly brace in pattern matching that we had in C#8. So just a review there. And another thing we can do is let's add an extensions class. And this is going to be a typical class where we're going to put extension methods, which means we have to make the class itself static. And I'm going to add a static method that returns a Boolean that says is valid. And it's just going to operate on a char. And in order for something to be an extension method in C#, of course, we have to provide this pointer on the very first parameter. And I'm going to use an expression-bodied method here to just make this a one-liner. And here we can say C is, in parentheses, watch this, greater than or equal to A and less than or equal to lowercase z, a lot better than having to do regular expressions, or greater than or equal to the 0 character and less than or equal to the 9 character. And this is one way where you can use these pattern matching expressions in C#9, and I didn't have to say C is greater than A, and C is less than Z, and C is greater than 0. A lot of the repetitive stuff we had to do in previous things with pattern matching, it can just be simply more succinct syntax. So more pattern matching examples. So these we had pattern matching in C#8, but this is additional sort of syntax sugar, so to speak, that they added additionally in C#9. Okay, so let's keep moving right along here. Next example I want to show is back on our main function here. What I'm going to do is, I have a lot of code I've written here. I kind of want to set this aside. So let's just say static void set aside. And I'm going to just, all my previous examples, put them all like that. And I'm just going to sort of collapse that to get that out of the way, so it's not distracting. I don't want to delete it because, again, for the people that download the code, I want you to see everything I've done. But I'm setting it aside, so ignore that. Now I have a fresh slate, so to speak, to show my next demo. So I'm going to come in here and I output a couple of lists. I have team 1, and that has a bunch of names in here, and team 2, and a bunch of names in here. And depending on your sports preferences, you're probably going to very quickly or not realize who these people are. And these are NBA players and their scoring averages, at least what their scoring averages were before the All-Star game happened in the middle of the season. And we have a func right here called overall average. And then we're outputting. And notice it's just like getting the average right here is using the average function, and then I'm outputting the average. So I'm seeing, essentially team 1 scoring average, team 2 scoring average. All right. Now let's run this. Oop, hold on one sec. Yes. So top level statements must precede namespace or type declaration. So the record for player, I'm going to stick this at the bottom. Remember, I mentioned that earlier when I first started the demo. You have to think of the top as like your main method. Once you start declaring classes and stuff, that has to go down below. All right, now hold up a second. If we look at what just output, this looks pretty suspicious, right? I mean, I didn't do all that math in my head that quickly, but like for team 1 and team 2 to both have identical scoring average down to the 100th, like something suspicious about that. It feels like there might be a bug somewhere, right? So let's have a look, a little bit of a closer look at our code to see what the case might be. Now, if we look at it, what accidentally happened here was, you can see that when I look at the average here's my input parameter, but I didn't use an input parameter. I actually used team 1. I accidentally captured the local variable from up here, and that's not what I meant to do. That's valid C#, but I didn't mean to do that. I meant to use the input parameter. So what I can use now is if I use the static keyword right there, this is a new feature of C#9 called static lambda expression, or you could say anonymous function, works for anonymous function as well. Well, I mean, they're the same thing, but different syntax. And notice that by using it, it made it a compile error, saying, hey, that team 1's, you can't use that. This is a static, this can't refer, just like a regular static method cannot refer to instance variables, same thing here. So this is a great feature because it alerted us to our bug. So now I can take team 1 away to say, force it to use a parameter. See, I was always passing team 1 and team 2 in as parameters, but I was accidentally ignoring them because I was using team 1 here, and the compiler didn't tell me I did anything wrong. So I accidentally captured that local variable I didn't mean to. By essentially making this a static method, I said you're not allowed to use any instance variables. And now that little feature just sort of helped me write code that was more bug-free. And we can see the Eastern Conference, or the Team LeBron has a higher scoring average. Okay, so that is static lambdas. All right, so let's keep going here. The next example I want to show is, let me come in here and I have a little method here called process. And in this process method, I'm just doing a simple each over whatever team is sent in, and I'm checking if they're valid, and I'm outputting a message. And then let's just call the method down here. So we'll say process, and we'll say team2. Let's just run the code. And you can see is valid, did fall into if statement. Apologize if there's any Jason Tatum fans. He had a lower scoring average. Okay. Now, if we look at this example here, what you may have noticed is that we have a method called process. It has a for each loop in the method, but we also have a local function right here, meaning a function inside a function, which was introduced in C#. Was it 7 or 8? Even I'm getting confused now. Either C# 7 or 8, local functions, was introduced. But however, they're somewhat limited. So for example, I was not able to use even simple attributes on local functions. So if I wanted to do something like this, where I say disallow null, and I probably need to resolve a namespace, I could not do that. That for whatever reason, and code still runs just fine. All right, everything still works. But prior to C#9, that was not allowed. So again, that's one of those features you kind of notice more so when you don't have it, because you're like, why doesn't this compile? Why shouldn't I be allowed to use an attribute? I can use an attribute on a method parameter in any other place in C#. Why can't I do it on local functions? Well, there's no reason you can't. So this is using an attribute on a local function. Again, what we start to see is that it just kind of makes C#9, some of these features just make C# more complete. A lot of the things that, some of the rough edges, why didn't this work? Now they just start to work. Okay, let's keep going here. So I'm going to show another example where I come in here and let's do, okay, simple case here where I have an event handler, object and event args, and I'm just doing console write line, and here I'm invoking that event handler here. And nothing too interesting, hello from event handler. Now, what is noteworthy about this code that I just put out here? And you can see this is very common, especially like win forms and that kind of thing, very common signature for event handler. And so sometimes you have code where, you know, the framework sort of enforces that thou must have a certain method signature, in this case, object and event args as a second one. But if you notice, the method itself isn't actually using sender or args. So it seemed like a lot of ceremony I had to go through just to create this lambda here with that, when I'm not actually using those in my example. So what you can do in C#9 is just use the discard that was introduced in previous versions of C#, in C#8. But now you can actually do it with the lambdas. So here we have lambda discard parameters. Again, these are real quick things here because these are not necessarily ones you'll use every day. But if you do have a situation where, hey, I don't want to have to go through the ceremony of doing this, I don't actually even use the event args, it just makes your code a little more succinct, cleaner, and easier to work with. Okay, just a couple more examples I want to show here. The next one is, I'm going to come down here, and I'm going to say team enumerator equals, and I'll say team1.getEnumerator, because team1 was a list, it implement IEnumerable, so I could say getEnumerator. And now I'm just going to do a for each over team enumerator. Now, the problem here is like, I'm getting a compile error saying the for each statement cannot operate on variable because enumerator does not contain public instance or extension definition for getEnumerator. And you're like, well, what are you talking about? This is an enumerator. Like, if it is an enumerator, why does it have to have a method called getEnumerator? Why doesn't this work? So let's dive into this a little bit more deeply. I'm going to come back to ILSpy, which I showed previously. In fact, I've added more code here, so I'm going to just do a little reload here. And you're going to notice that in this code that I had previously written, we're going to come into the program here, and I want to show a couple of things here. This process method, which was using a for each loop, I'm just trying to find an example of a for each loop here. Keep in mind, there actually is no such thing as a for each loop in IL. In intermediate language, there is no for each loop. For each is a C# construct that it turns it into a state machine. Let me talk about what I mean by that. So if I come back and look at the list of player, I'm just at F12 to look at the definition of a list. You can see a list implements the interface IEnumerable of T, if I go and then say, well, what's the definition of IEnumerable? We can see that right here, it has one method called getEnumerator that returns an IEnumerator. So there it is. There's the magic. I had already called getEnumerator. It returned an IEnumerator. And if we kind of dive into this as well, what we're going to see is that it has a current property. So each time you go through the loop, what's the thing that's current? And then you can also see that it has a move next and a reset. So there is no such thing as a for each loop in IL code. It's just a state machine pattern that it implements this pattern. And let me go prove that to you. I'm going to change this instead of C#. I'm going to change it to IL with C# comments so we can actually see what's happening behind the scenes. So right here on line 20, you can see that it's put a little comment in for each, which is really a call to the getEnumerator that gives us the enumerator. And then what you're going to see is down here on line 31, you have a call instance to the getCurrent, and it's going to do whatever it needs to do. And then at the bottom of the loop, so to speak, in air quotes, you're going to see that it makes a call on line 80, a call instance to the move next. So for each loops in C# are really just a state pattern. Okay, so now let's get back to my original point here. My original point was this is an enumerator. So I should be able to, like logically, I should be able to for each over it, right? And so just having a rule that this thing doesn't have a getEnumerator function doesn't let me loop over it just seems a little unfair, right? It seems a little like limited. So what you can do now in C#9 is you can add an extension method to compensate for that. We can fake it. We can make it look like this has a getEnumerator method by tacking on an extension method to it. Let me show you what I mean. So if I come in here and say static IEnumerator of T, and there's my getEnumerator method, and its extension method, so we have to use this IEnumerator of T. And this is a pretty simple one-liner, like, hey, just return it. Because we know that thing has a getEnumerator. We know this is it already is an IEnumerator. Now, you might notice, like, well, hold on a second. Why are we still getting a red squiggle? Well, if we remember all the rules for extension methods, rule number 1 must be inside a static class. Rule number 2 must be static itself. Rule number 3 must have this. Well, there's a 4th rule we need to have as well, which involves namespace. We have to have the using for the namespace itself in the consuming code. And because we're in a top level statements, we're not even in a namespace. So if I just add the using for it, and now the compiler error has gone away, and we can for each over that, no problem. We've tricked it into thinking that it's got a getEnumerator method. Okay, now one final demo I want to show has to do with covariant return types. So let's come in here, and I'm just going to literally add a brand new project. We'll just call it console application, console app 1, because that's the extent of my creativity. And what I'm going to do here is I'm going to just insert a snippet of code. We have an abstract base class of a person that has a first name and last name, and then an abstract method called speaker. And we have a fireman and a policeman that inherit from the person. Fireman has a number of fires extinguished, this number of speeding tickets written. So what we're going to do is we are going to override the speaker class, and we'll just return the instance just for simplicity. So yes, the person that's going to speak is the fireman, and the person that's going to speak down here is the policeman. Now, what we're going to see about this code is that we have this abstract method here called speaker. Give me the speaker. And we've implemented, we've overridden it here, we've overridden it here. But notice in all cases, it's returning a person. And what we actually want is, instead of returning a person here, we want to return a fireman, because it's a more derived type. A covariant type is more derived. So if I change this to fireman, it will just work. Now, this is .NET 5 right here, right? So let me just prove this to you here. Let's go .NET 5. Yes, I'm going to copy that. And I'm going to change this to C# 3.1 to prove this to you. And now notice we're getting a compile error. It says, okay, this target runtime does not support covariant return types on overrides. You must use the base class of person. So if we're using prior to C#9, we have to use person to make the C# compiler happy. But with C#9, we can actually fix this because C#9 has the ability to have covariant return types. So let's not leave this. Let's actually fix this here. Oh, sorry about that. Let's change this to net 5.0 to change this back, and our error goes away. So this is a feature of C#9 covariant return types, which is a more derived type. So let's change this one down here. Let's change this to policeman, giving us a more derived type than we could have. And again, this is one of those features that you're looking at like, well, why can't I do this? I should be able to do this. And yeah, if you felt that way, yeah, you were right. The C# team agreed with you, but they just didn't have time to implement it in previous versions. And now that we're on like version 9 of the language, it's getting to the point where C# is getting pretty mature, and a lot of the features that in previous versions of the language they didn't have time to get to, that now they have time to get to, and they can knock a lot of this stuff out. Okay, so a couple other just quick things that were added to C#9 that I didn't show is native ints. So depending on if you're running on a 32-bit machine or 64-bit machine, you can actually change the value of the integer by using nint or nuint, sort of like an int pointer that we previously had, but a native keyword. Function pointers, you won't use that very often, but that is something that's available. Also, locals init. Typically, that's how when we declare an int like this, where it's int of x, we know that x is going to be 0, even though we haven't explicitly assigned to it. And generally, that's a good idea. But in absolute performant code, sometimes you want to skip that initialization. And so just a couple of code generation features that were enabled as well. So we covered a lot of features in this presentation. I will make, even though this PowerPoint deck only consisted of 3 or 4 slides, I will make the PowerPoint downloadable for everyone. If everyone goes to my my Twitter handle is right here, and I will put a link out tonight or tomorrow that contains a link to a zip file that will contain the PowerPoint and all of the code samples that I showed in this demo. And with that, it looks like it's 2:55, so I'm getting tight on time here. I will stop here. Okay, and if questions come up later, there's my email, there's my Twitter, so don't hesitate to reach out to me as well.
Thanks a lot, Steve. As always, really enjoyed your talk. I really learned about records today, so that was quite interesting. So I'm getting ready to use those. So thanks a lot, Steve.
All right, great. Thanks a lot. See you later.
Take care.